Analyze the thermodynamics of the reaction. The reaction is given as CaCO3 is in equilibrium with Chow plus CO2 quad delta H degrees equals 178 kilojoules per mole of reaction because the enthalpy change, delta H degrees, is positive. The reaction is endothermic. It absorbs heat. We can write heat as a reactant. Heat plus CaCO3 is in equilibrium with Chow plus CO2. Determine the direction of the required equilibrium shift. The question asks what change will decrease the amount of Chow in the system. Since Chow is a product, on the right side of the equation, we must find a disturbance that shifts the equilibrium to the reverse direction, to the left. Apply Le Chatelier's principle to temperature changes. According to Le Chatelier's principle, changing the temperature of a system at equilibrium shifts the reaction to counteract the change. Lowering the temperature is equivalent to removing heat, a reactant, from the system. The system counteracts this cooling by shifting in the heat-producing exothermic/reverse direction to regenerate the lost heat. Shifting to the left consumes the products Chow and CO2 to produce CaCO3. Conclude the correct option because a shift to the left successfully decreases the amount of Chow in the container. Lowering the temperature, option B, is the correct choice. The correct answer is option B, lowering the temperature of the system.